Okay, so good day. So this is the analysis of complex truss using substitution. So complex truss can be analyzed using the method of section. Okay, so let's just try the method of substitution since this is something new compared to your statics. So if you are using method of substitution, first look for a member that is to be replaced. So mag-select kayo ng isang member of the given truss or a given bar to be replaced. Then place a new bar member. So make sure that if you are to remove that member, then replacing it, still the truss is stable. So for this case, we have this complex truss. It is loaded with 50 kilonewtons at joint F. So obviously, since 50 kilonewtons is midway, so support reactions natin, 25 kilonewtons upward, we don't have a horizontal force, so zero horizontal reaction. So for this example, okay, the same in your module, we are to replace member CF. So take note, again, this is pass-through. So it is not considered as a joint. It is not pin, so hindi siya counted as a joint. So we are to replace CF. So ang gagawin dito, we are to replace CF with the new member BD. Okay? So we have to replace CF, we have to remove CF, then replace it with member BD. So ano yung purpose nun? So that we have joint C and joint F to have two members per joint. As you can see in this, the original truss, every point, how many members or every joint? So sa kada joint, we have 3 members. You cannot do the method of joints. So we are to replace member CF, we are to remove CF, then replace it with this member BD. Then, after removing CF, we replace that member with a unit load. Okay, so unit load. So if we say unit load, okay, the magnitude is basically equal to 1. And it is under tension. So replace it with a unit load 1. So assume natin 1 kilonewton, for example. So we are to compute for the loads or compute for the bar forces. Okay, due to the unit load is equal to 1. So let us determine the bar forces using the unit load 1. So we have, okay, pwede natin unahin, this is, let's say, at joint C. So at joint C, so nag-a-act dyan yung unit load natin na 1. So as you can see, if this is, one unit load is downward, what should be the direction of the bar force for member BC and member CD? So since this is downward, we will assume that these two will be upward. So si BC pataas, and the same with member CD. Take note again, since we are doing truss analysis, if the force is towards the joint, they are considered to be compression. So we are assuming BC and CD to be compression. So we are doing summation of forces, vertical equal to 0, upward forces to be positive. What is the slope of member BC and CD? So we may assume, kung mapapansin nyo, identical naman si BC at saka si CD. So BC is basically equal to member CD. And the slope, we have, that is 4 horizontal, okay, 2 vertical. Okay, so this is 2 vertical, 4 horizontal. This is a square root of 20. So this is square root of 20. Can we simplify that one? Square root of 20. That is the same as 2 square root of, okay, pareho lang nito sa 2 square root of 5. So again, member BC is the same as member CD. So what is the vertical component of BC? Gamitin ko na lang twice, gamitin ko na lang BC since they are similar, BC and CD are similar. BC vertical component is 2 divided by 2 squared up, 5. Then minus 1 equal to 0. So what will be the magnitude of member BC? That is the same as the magnitude of the bar force caused by the 1 unit load. That is equal to the same as CD is equal to so this is the same as 1.118, and they are both compression. Okay? So BC and CD with a magnitude of 1.118, both compression. That is for at joint C. So we proceed to the next joint, that is at joint F. Okay, so we have joint F. As you can see here, we have the 1 unit load is upward. So if this is upward, so dapat yung direction ng member, that is for member AF, the same with member EF. So both of them, assume direction natin will be downward. What will be the slope of these two members? We may assume that AF is equal to EF, the magnitude of the bar forces. Mapapansin nyo, equal lang naman sila. They are identical. So the slope is, that is rise of 1, horizontal of 4, so 16 plus 1, this is the square root of 17. So you have summation of forces, vertical equals 0, upward forces to be positive. So we have the upward force is 1 minus 2. Gamitin ko na lang si AF, that's why mag-multiply ako ng 2 since dalawa yan. So I hope that is clear. So we have AF. What is the vertical component of AF? The same with EF, that is 1 divided by the square root of 17. And this should be equal to 0 for equilibrium. So you'll be having the magnitude of AB, pareho lang yun sa magnitude ng bar force for EF. Okay, so we'll be having a value of 2.062. So as you can see, they are away from the joint. So kapag away from the joint, these two are under tension. So that is for member ABN. Okay, so ABN member EF. So next joint. We will proceed to the next joint. So we have now for BC and CD, AF and EF. Okay, so pwede ako mag-proceed dito at joint. Okay, let's try joint A. So we have at joint A. What are the members connected at joint A? We have AF, yun yung nakuha natin kanina, 1.118. Then we have member AD. So take note, if we are to observe this one, member AD is similar to member BE. So equal lang yan. So AD is the same as member BE. So as you can see, we have here, AF is to the right, inclined to the right. So I will assume that member AD should be downward to the left. So kung meron tayong pakanan, dapat meron tayong component na pakaliwa for equilibrium. So this is the slope of member AF kanina, that is 1 vertical. Ito yan. Sorry, it should be not AB. AB yung nasulat ko dito. So it should be AF. AF, so yung nakuha natin dito is 2.062, not 1.118. AF. Then for member AD and BE, so for AD, what is the slope of AD? So AD, the rise is, we have 5 meters. The run, horizontal, that is 8. So this will be square root of 64 plus 25. 64 plus 25 is equal to, this is the square root of 89. So we'll be having the summation of forces, horizontal equal to 0, to the right forces to be positive. Horizontal component, 2.062. Horizontal component is, this is 4, ito yan. So 4 square root of 17. The square root of 17 minus AD. Horizontal component of member AD is, that is 8 divided by the square root of 89 equal to 0. So hindi mo nakasali si AD since that is purely vertical. So let's compute for this one. So this is equal to 2 point. So we have AD is equal to, pareho na rin yun kay member BE again. So this is AD is similar to member BE. And that is equal to, this is 2.359. And as you can see, this towards joint A. So this is under compression. So this is for AD and I member BE. So lastly, we may proceed now to joint B or joint D. So dito at joint A, so pwede pala natin kunin si AB. Yun pa yung wala dun sa joint B. So if this is upward, downward, okay, I will assume that AB is upward. So gawin natin yan before joint B. So this is by summation of forces, vertical equal to 0. I'll be assuming AB to be upward. Ano yung downward dito? That is si AD. So this minus, vertical component is 5 over the square root of 89. What is the magnitude of AD? Yung na-compute, we have 2.359. So that is downward. This is upward plus 2.062. Vertical component is 1 divided by the square root of 17 equal to 0. So let us check if the assumed direction of AB is correct, if it is upward. And is equal to 0.75, and it is under tension. But again, if you are to observe, kung mapapansin nyo, si AB is similar to member DE. So that's why we may consider, or we may conclude that AB is the same as DE. Pareho lang sila, 0.75, and both are under tension due to the 1 unit load. Alright? So this is, these two are under tension. Then we may now proceed to joint, o yung joint B kanina. If we have a joint B, we have 4 members, that is AB. So we have AB, the magnitude of AB is 0.75. That is under tension, so that's why it is away from the joint. Then next is we have a BE. Ano yung magnitude ni BE? That is 2 point. So this is for member BE equal to 2.359. Okay, towards the joint cyst, it is under compression. While we have the same kanina, this is member BC equal to 1.118. So towards the joint cyst, it is also under compression. So we may now compute for the substitute member. Ito yung substitute member natin si BD. So that is, okay, assume to the right. We have BD. Bakit to the right? For a reason, BE and BC, their horizontal components are towards the left. Kung pakaliwa ito, pakaliwa na rin yan. For equilibrium, we need a force to the right. So we have, this is by summation of forces, horizontal equal to 0. So we have a BD minus, ano yung slope ni BC kanina? This is 2 vertical, for horizontal, 2 square root of 5. So horizontal component, we have 4 divided by 2 square root of 5 of 1.118. Then minus, ito, for BE, this is 2 point. This is 2.359 horizontal component. What is the slope of BE? 8 horizontal is to the square root of 89 equal to 0. So let's compute for the value of BD. So the bar force for member BD for the substitute member due to the 1 unit load. That's equal to 3.000. So we may assume that this is 3. So as you can see, it is for 3, it is away from the joint B, so it is under tension. Okay, so those are the bar forces per member due to the unit load. So I hope wala akong nakaligtaan dito. So okay. So after the computation of the bar forces due to 1 unit load, ang isusunod niyo is compute the bar forces due to the actual load or due to the load 50 kilonewtons. Okay, so next thing to do, so matapos natin i-compute yung mga bar forces due to the 1 unit load is we have to compute all the bar forces due to the real load or due to the actual load 50 kilonewtons. So as you can see, we replace a CF with member BD. Okay. So we have first, this is at joint F. So at joint F, we have the members connected to that member. We have member AF and member EF. So the slope of member AF and EF kanina, this is 1, 4, and the square root of 17. Again, the magnitude of the axial force for member AF is equal to the member EF. So this is by summation of forces, vertical equal to 0, upward forces to be positive. So twice, I'll be just using AF. So again, bakit 2? Kasi equal lang naman yung dalawa. Okay? I'll be using AF. This is vertical component, that is 1 divided by the square root of 17. And minus the downward load 50 kilonewtons equal to 0. So this will be the magnitude of AF, the same as the magnitude of member EF equal to, so let us compute for that value. This is equal to 100. This is 103.078 kilonewtons. So both members, as you can see, towards the joint. So pag towards the joint, it is under compression. So AF and EF both are under compression. So that is at joint F. So next joint, pwede tayong mag-proceed sa joint A. So we have at joint A, how many members are involved at joint A? We have AF, which is, na-compute natin kanina, 103.078. At joint A, take note, meron tayong support reaction dyan na 25 kilonewtons, since that is a downward load. Then we have member AB and member AD. So again, member AD is similar to member BE. So bakit natin sinasabi na similar? Since the load is midway of this truss. So, just in case na meron tayong other load other than 50, so hindi mag-i-equal yung dalawang yan. Okay? So, we are to compute. Ano yung pwede natin makompute dito? So, first thing to solve, we may solve first for member AD or BE. Since this is downward, we will assume that member AD, okay, the axial force for member AD this time will be upward. Okay, kung downward si AF to be in equilibrium, or kung to the left yung component ni AF, we need a force to the right. So we can have it by summation of forces, horizontal equal to 0. So to the right, that is member AD, horizontal component is 8 divided by the square root of 89. Okay, then minus AF, 103.078. Horizontal component is 4 divided by the square root of 17 equal to 0. So we'll be having the magnitude of the axial force for member, yan naman, member AD. So may muna susulat yung AD. So we'll be having a magnitude of, so AD is the same as BE, equal to 117.925 kilonewtons. So as you can see, the direction is away from the joint. They are both under tension. Okay, that is for member AD and BE. So ano yung natapos dito? We are able to compute for EF, AF. Okay, so this is BD and BE. Okay, pwede na natin kunin si AB. This is by summation of forces vertical. So this time, since parang mas malakas yung AD na upward, again, I will assume AB to be downward this time. So wala namang problema kung mali yung assumption, lalabas lang ng negative yung sign. But take the opposite kapag ganun. So we'll be having summation. This is the summation of forces vertical equal to 0. Upward forces to be positive. What are the upward forces? The support reaction. We have 25. Plus, ano ba yung pataas? Yung vertical component ni AD. That is 117.925. Vertical component is 5 divided by the square root of 89. Minus downward, CAF, that is 103.078. Vertical component is 1 divided by the square root of 17. And assume natin AB is downward, so minus AB equal to 0. So let's compute for the magnitude of AB. So if you are to observe, AB is similar to DE, so pareho lang sila. Let us compute. That will be equal to 60. We have 62.5 kilonewtons. And as you can see, the direction is towards the joint, so this will be under compression. So AB and DE, they are under compression. Okay, so we are able to compute for these two. Okay, so last three, BC, CD, and BD. So we may proceed at joint B. Okay, so this is at joint B. We have the members AB. AB is under compression, kept towards the joint. BE is under tension, so away from the joint. So we have BC. I will assume it as compression. So i-assume siya as downward. So we may compute for BC. Bulan na. Medyo malakas yung ulan. So this is by summation of forces, vertical equal to 0, upward forces to be positive. AB, we have 62.5 minus, this is equal to 117.925. Ano yung vertical component nito? So again, yung slope nito is 8 horizontal, 5 vertical, square root of 89. So that will be, vertical component is 5 divided by the square root of 89. I assume that BC is downward. Ano yung slope nito? We have 2 vertical, 4 horizontal, this 2 square root of 5. So minus BC, vertical component is 2 divided by 2 square root of 5 equal to 0. So let's compute for the magnitude of BC. So again, member BC is similar to member CD. So the same as CD. And that is equal to so yung lumabas dito is 2.795 times 10 raised to negative 4. As you can see, this is exponential to the negative 4. This is approximately equal to 0. So, sobrang liit niyan. Okay? So, therefore, which means BC and CD are 0 bar member. So, 0 force member equal to 0. So, walang force dito. So, this is 0. Then we have for member BD, okay? So if this is already towards the right, and this is 0, which means, i-assume natin that BD should be to the left, or that is towards joint B. Kapag towards the joint, it is assumed to be compression. Summation of forces, horizontal equal to 0, to the right forces to be positive. Ito yan. We have 117.925. Horizontal component is 8 divided by the square root of 89 minus BD and BC. Kaya lang kung hindi ko rin sasama si BC since that is 0. And it's equal to 0. So we'll be having the member BD. Actually, BD is our substitute member. .0002. So we assume this is as 100 kilonewtons and it is under compression. So again, why is it under compression? The assumed direction is correct towards the joint. So those are the bar forces due to the actual load, 50 kilonewtons. Okay, so we are now able to compute for the bar forces due to the unit load and the bar forces due to the 50 kilonewton real load. So how will we compute for the actual bar forces? Okay, so we will now compute for the actual bar force. So the actual bar force equal to, this is the bar force due to the real load, or that is due to the 50 kilonewtons, plus we have the load due to, that is due to the 1 unit load multiplied by the value of U. So this is AR, ito naman yung A sub U natin, this is the actual load. So what is the value of U? So we may start on, magsisimula tayo dun sa substitute member. So ito yung ating substitute member, the member BD. I start with the substitute member BD. So what is the actual bar force for the substitute member BD? Yung nilagay ko dito kanina. Okay? So take note that this is just an imaginary member, substitute to the member CF kanina. So since that is an imaginary member, the actual bar force for member BD is basically equal to 0. So 0 yun kasi it is non-existing bar force. So starting with member BD, for member BD that is a 0 AR. What is the load for member BD due to real load? So nakuha natin dito, negative 100. So by the way, kung bakit nagtataka sa mga signs, so take note that if we have a compressive force for that bar force, for that member, it should be negative. Okay? For tension, or members under tension, positive. So since BD due to real load, it is under compression, so it is negative 100 plus A sub U. What is the load for member BD due to the 1 unit load? Nakuha natin kanina is 3. So this is equal to 3 multiplied by U. So we'll be having the value of U as transpose positive 100 over 3 kilonewtons. So that will be the value of U. 100 over 3. So for example, we are going to compute for member AB. So for member AB, that is the actual bar force for member AB is equal to A. Or pwede natin idiretso. We'll be having the actual bar force for AB is equal to A sub R. What is the A sub R for member AB? It is negative 62.5 since under compression. So this is negative 62.5 plus A sub U for member AB, that is 0.75. What is the value of U? The value of U is equal to 100 divided by 3. So this will be the actual bar force for member AB. Okay, so kunin natin, that will be negative 62.5 plus 0.75 of 100 over 3. So we'll be having a value of negative 37.5. So this is negative 37.5, which means it is under compression. So this is in terms of kilonewtons. And that will be the actual bar force for member AB. So that will be the pattern. Kung gusto naman natin si BC, And we have BC. What is AR for BC? That is 0 plus A sub U for BC, we have that is negative 1.118. Then multiplied by U, this is 100 divided by 3. So we'll be having the value of member BC, that is so we'll be having 37.267 kilonewtons. And again, it is negative. So this is negative 37.267. This means also under compression. So again, sin yung kapareho ni AB kanina. AB is similar to member DE. So si DE, ito yun. So this is negative 37.5, also under compression. Kapareho ni BC. Kapareho ni BC is CD. This is negative 37.267, also under compression. Okay? So, pwede natin i-compute si EF. So, EF, that is negative 103.078 plus AU, that is equal to 2.062, then multiplied by U, 100 over 3. So this is equal to 34. This is equal to 34 negative 34.345, also under compression for member EF. So, sino naman yung kapareho ni member so sino kapareho ni EF? So EF is negative 34.345. Si EF EF is the same as AF. Yung kasunod pa lang. So this is negative 34.345, also under compression. Then we have for member AD. So AD, sino ba yun? Ito. So we have this equal to 117.925 plus A sub U, that is negative 2.359 multiplied by 100 over 3. So we have the value of the 39. This is positive. So we have 39.292. So it means kapag positive, under tension. So AD is similar to BE. So this is the same as 39.292. Also under tension. Then we have CF. So that is 0 plus 1. So 1, yun yung replacement ni CF. That is yung 1 unit load na under tension multiplied by 100 over 3. Actually, yung nakuha natin dito na U, yung nakuha natin dito na value of U, that is the actual value, actual force for the replaced member, yung tinanggal natin. So this is the same as 33.333. So that is positives, which means under tension. And obviously, for member BD, that is 0 since that is only an imaginary member. This is our example for complex truss using substitution.